Hello, welcome back to the channel. Sorry, it's been a while since the last upload. Life got in the way. So I want to show you a couple of the projects I've been working on since then, which is this harness that allows me to play guitar stood up again, and this guitar, which is the current state of my effort to 3D print a guitar. I hope you agree it looks a little bit prettier than the last one you saw. But for right now, I'll play us in with the traditional intro music. Now, one of the things that people occasionally get all into semantic wrangling about is what's the difference between a guitar and something that's just shaped like a guitar, and that generally tends to come up if someone's asking themselves or accusing someone else of not being are they or are they not really a luthier. Now, I don't have a lot of time for those arguments. The difference between a guitar and a guitar-shaped object is you could do a performance on a guitar, and you couldn't really on a thing that's just shaped like a guitar but won't hold its tuning or whatever. So this guitar is now a guitar because it's just done a performance and you all saw it. Um, and therefore, anyone who made this guitar is a luthier, which blesses me with that property. So this guitar is 3D printed. In order to make that work, you have to do some extra. You have to be worried about the strings bending the body into multiple pieces because the plastic's very flexible. I'll demo that in a minute. But what I've done in this case is stick a steel rod of all thread up the spine of the guitar, so it runs from just under the bridge here to under the neck cavity here. Internally, there are plastic structures connecting it as firmly as I can with PLA to the rest of the guitar, and that is what's giving me the force to counter the pull of the strings. I think there might be other ways to do it, and those other ways might in fact be better because it's not actually that pleasant trying to tighten a 3mm hex key to counteract all of this force. But it's working, and as you've heard, the guitar is in tune and stays in tune adequately. It's not the best tuning stability of all the guitars I own. It's also not the worst, so it's in the spectrum of what it is to be a guitar. So that's a E minor chord. Now I'm going to do the same thing, and then I'm just going to press with my elbow on this piece here. And all of that bend is body flex that I'm able to create by just pressure between my two hands as I'm playing that chord. And if I reposition the guitar slightly and then push here, I can get the opposite bend. Now, in a moment when I change guitars, we'll try that on a wooden guitar, and just for point of comparison, because I actually don't know how much, if actually it is true that this is more flexible than a similarly dimensioned wood guitar. Let's talk through though why I wanted to 3D print a guitar in the first place. So selfishly, I've got a problem with heavy guitars, and this is the lightest way to make a body because it's mostly air, a little bit of plastic, and then I can make a guitar at a lighter weight point for the same dimensions than I am capable of making with wood. I'm not saying that a really skilled machinist couldn't make a guitar of these dimensions out of wood that's comparably light or perhaps even lighter and strong enough. I don't know that it could be done. I don't know that it couldn't. But I can't do it, and I can do it out of plastic. And then also there's design features that I specifically need or feel like I want that I can't find in other guitars that are commercially available. So if I so for example, I like having these feet to support the guitar when I put it down. But I also want to be able to leave the thing plugged in while I put it down. So if I'm playing guitar and the doorbell rings for a delivery and I have to go and deal with it, I don't want to have to unplug the guitar, sort that out. I just want to be able to set it down. So let me just do that. Done. And pick it up, and I can reattach it to myself. And it was never unplugged. Now, you might be wondering why this big spanner shape here. Well, partly in order to look cool, partly to provide clearance for that, and to provide a secure anchor point for the feet to sit on. But also, it was in my mind because I was starting to be able to play stood up with the harness, that I wanted to be able to put a wireless pack in that cavity as well. So this isn't a wireless pack actually, but it's the same dimensions as one, and so I can put that in there and also set it on the ground without it hitting the ground, and it doesn't protrude out of the front surface of the guitar or the rear surface of the guitar. It's actually quite well protected in there. So that's second design feature that I wanted to put in. And then you might have seen the short video about it, but I need these Dunlop strap locks just for my ease of use, and because with the harness, which I'm going to talk about a lot more in a moment, and because of that, and integrating it with the feet, I had to do a bunch of custom work, which you may have seen. Anyway, let me just show you a little bit more on this guitar in its. I'll switch the amp into rock and roll mode and find a different pick, and show you some other stuff. Got a lot more gain now. That's probably enough of that. As it doesn't. So, just want to talk briefly about my relationship with playing guitar. If I sit down, I find it a lot harder to know where my left hand is on the fretboard. When I'm stood up with it on a strap, for some reason I can navigate the fretboard without looking at it much easier. Don't know why. Don't even really care why. I just need to know that it is. And so being able to stand up gives me a lot more freedom. I can bob my head, tap my feet in time to the rhythm, which helps me keep pace with what I'm trying to play. And it just seems to let me relax a bit more into the playing. Now, the reason that's not going to come across on video so much, perhaps, is it's then quite stressful to be recording myself. I'm now trying to do, so it's as though playing the guitar with it hanging off a strap is just the one thing. If I'm sat down, I'm now playing the guitar and I'm sat down, and that's more complicated for me. At the moment, I'm playing the guitar and I'm worrying about, is this recording working? Is the video recording working? And so I'm correspondingly less relaxed. But so, as I say, it may not come across on the video, but I find that I believe that I play better, and I certainly feel better while playing when I've got it on a strap and I not needing to be sat down. So I guess what I'm saying, it makes more of a difference to me than perhaps will be evident from the performances you're seeing. Now, I just show we're done now talking about this guitar, I think. Although the rest of this video in a moment is going to be about the technology behind making this guitar and how I'm planning to release that for everyone. But we will now just talk a bit about the harness, and to do that I'm going to switch guitars to show you how that works. So on a normal guitar strap, you would possibly leave the strap attached to the guitar, and then you just put a new strap on with a new guitar. With this, I needed a system that lets me quickly and quickly change from one guitar to the other with the same strap, because it's a real pain to get this harness on and off, but also hold the guitars securely while they're being played. And that's why I'm using these Dunlop strap locks. They do exactly what I want, and I'm happy to say the Dunlop company saved me the hassle of having to invent the same thing. Let's switch to a weightier guitar. So this is my PRS SE NF3. So as you can see, it does work. That change of guitar wasn't actually much longer than it would have taken if I were having to take a strap off, put a new strap on, in my experience. And now we're ready to go with the new guitar. Obviously, this one has a bit less pokey pickups than the previous one, so it's quieter for me in the room. I'll equalize the audio levels so you won't notice. So this guitar has a floating bridge, which means if I want to do that vibrato effect, I can do that way. But let's see what happens on this very solidly built wooden guitar if I try and do it by bending the body. I'm hearing some movement there, but not to the same extent as we got on the PLA guitar just now. So one of the things with having a harness that's fixed to you and changing the guitar like this is not all of the strap buttons are going to be in the same places. So the spanner guitar I just showed you has strap button at the tail and at the head end, and so does this. So that's easily compatible. But let me show you what happens if I switch to my Strandberg. So the tail end strap button is fine, but at the head end it's on the back side of the guitar. It's not here. That means I need to reorient this strap. Now, to do that, I've used these. It's from a pack of mole rigging stuff for soldiers to use, I suppose, or people who want to play active soldiers on the weekends. And that allows me to rotate this strap so that it works in this position, which is letting me switch from one guitar to the next across different styles of mounting very quickly. Now, I have guitars also where this applies at the other end, but obviously the same solution works. Now, this harness is a very long way from perfect. I need to do something about managing this excess strap while I'm playing, because that can get in the way and perhaps mute the strings. I can't just make it shorter. Like the three guitars I've shown you there don't need the strap to be any longer than this, but if I switch to a guitar where the strap button is right behind the neck joint, I will need this to suddenly be 6 inches longer. So I need to somehow maintain the right level of adjustability and make this a bit easier to manage. It is hard to change the length of these dynamically, so I haven't been doing that in front of you. If I were going to play any of these guitars, I would want to precisely tailor the length of these to that for the session, and then it makes, changing from one to the other, it still works, but you're only going to have the perfect playing position for one of them. So in this case, it was set up for the Spanner guitar. I think this band here is too narrow. It's cutting in a bit into my body. I need that amount of pressure on my torso, or it just slips down, and I can't support it over my left shoulder because that's what hurts me. But I think I can do a better job of spreading the load across a bigger surface area so it feels less pinchy, and there might be some structural things I can do about getting the weight, some of it, over to my right shoulder to a greater extent than it currently is. At the moment, the guitars are essentially hanging from my rib cage, which is, it works and it's much better than using it over my left shoulder, but it is restricting my ability to breathe as deeply as I could if I weren't wearing the harness. It's not to the point of causing me a suffocation risk or anything, but I do feel it is restricting me, and I'm gonna undo it now, also to show you how awkward it is to put on. So taking it off once it's on is actually pretty easy, and I'll buckle it back up so you can see the component parts. So we've got this piece goes over my right shoulder, this piece ends up nearly round my back, up under my right armpit, which is where the conventional guitar strap comes down, and this goes to the tail end of the guitar. Then this bit goes under my left armpit, and this bit hangs down from my left pectoral to support the head end of the guitar body. But I can't get this back on in its current state. I have to loosen that chest strap. Then I need to put my arm through on the right side, obviously. And now there's a lot of webbing stuff behind me, and it's moderately difficult to tell which piece is which and not get it twisted up as I bring it round. So, because I don't want twists in the strap will give me a pinch point, so I had to sort out a twist that I picked up there. Then I can plug that together Now I need to put it right up under my armpits and then tighten it till it is too tight for comfort in terms of breathing and so forth. Fully deep breaths. It's probably still too loose and it is restricting me already. And then I can put a guitar on it, and that load will pull down on here, which causes this plastic piece to poke into my left pec here, and this end of things seems fine. So I actually don't seem to have a problem with what's going on the right hand side of here, but I need to do something about this. If I can get more of this load transferred up to the right shoulder, perhaps with a strap across there, I don't know yet, and maybe widen this and give it less of a tendency to torque around and create a hot spot. That's what I have to try and solve. So but so my current assessment is this is a lot better than not being able to play the guitar stood up. I'm having a lot more fun. It is I tried all the ways people have suggested of wearing a conventional strap over the right shoulder. It just doesn't work for me. I tried the very padded, very wide, very lightweight straps over my left shoulder. It still causes the original problem. And I don't think I've ever explained to you what the original problem is, but I crashed my bike into a tree and broke my collarbone. Then I had surgery to piece that back together, and as a result of both the crash and the multiple surgeries I ended up needing to have it put back together, I've lost a bit of blood flow effectiveness through that area and some nerve function in this area. Now I'm lucky in that it hasn't affected my ability to feel my hands, fingers, and to play the guitar. I'm thankful for that every time I pick up the instrument, because that would have been a nightmare for me. But all that's happened is I can't really feel anything in this kind of area of my body. And the reason that's problematic is because it intersects with the reduced blood vessels I've got in this area. So I have blood going into my arm and coming back out at the usual rate for normal function, or enough of a rate for normal function, as long as I don't put anything on this shoulder. But if I do rest anything across this shoulder, it tends to cut off that blood flow, because there's not the extra. It doesn't have the alternate paths it can go where that it would normally take if you're wearing a heavy rucksack or something. So if I put anything on my left shoulder, it will cut off the blood flow. And the problem is I won't notice that that's happening, because the nerve that would be telling me about that also doesn't work. And so it waits till I get the first observable features like pins and needles in my left hand. And at that point, stuff in my arm is dying already of lack of oxygen. And so if I fix the problem of the blood flow, immediately I notice the pins and needles in my left hand. I then will have about 2 weeks of quite severe pain and weakness in my left arm as all of that damage I just did gets repaired. And I really just, I have to be super vigilant not to inadvertently put any loads across my left shoulder. So it's really giving me a difficult design problem to solve if I want to be able to play guitar stood up. And I'm happy to have got the solution I've got so far. As I say, I think it can be improved. The next time I show it to you, hopefully it will have moved on from where it is. I would hate to think that where I've got it now is the best I can do. But yes, anyway, the remainder of this video I filmed yesterday, and it will show you some of the technology behind making a printable guitar, and I'll explain my intent to release that technology to the rest of the world. I've got model pieces for what you must remove from a part in order to create the necessary conditions for mounting the various kinds of guitar pickup that exist and the various kinds of guitar neck that you might be reasonably using as a donor neck. So at the moment, that's the Fender Stratocaster style neck and the Fender Telecaster style neck. As and when I encounter other kinds of neck and neck pocket that I think are reasonably standardized, that would be something you could use for your own guitar body, I will make the tooling for those. And as I go through different kinds of pickup, I'll make the tooling for those. But for right now, I just have the Strat and the Tele, and at the moment, as I'm talking to you now, I only have the P90 pickup tools done. So I've got a new empty SolidWorks document here, and the rules are that we start on the top plane, and this little dot here is on the front face of the guitar body, and it is in the middle of all 6 strings. If you're using 7 strings, it would be in the middle of all middle string of the 7, and so on and so forth. And it is at the theoretical line of the bridge goes vertically this way. So the neck is going to be over here somewhere. The player is behind this plane. The strings are in front of this plane. The bridge is going to cover this dot somehow, and then our pickups are going to be over here. That's the lay of the land. Now, you actually, to make a body, don't really need to worry too much about those details because of what I'm going to show you, but I think it's important to understand how the principle, this scheme works only because everything is originated here with a common view of what that means in real space and what these axes mean in real space. And there are also some limitations around like how maximum and minimum thickness of the body in various areas for pickup. Like you can't make the body shallower than the hole the pickups need to be mounted into, because otherwise it won't be physically possible to construct the guitar. Obviously, there are other more severe constraints when we're talking about 3D printing, in that if you make it too thin, it will still break. And as I say, those constraints are probably more of a limitation than the constraints I'm imposing because of how the parts are mounted. But let me show you really how you're going to design a guitar in this system, and it doesn't actually start with making a sketch. What we're going to do is we're going to insert we're going to insert parts from, so we're going to untick part material and body material, and we're going to insert we're going to insert the bridge tool, and we're going to say okay to everything. We're not going to change its position. It's very important that we don't change its position, in fact. Then we're going to stick in a bridge pickup with the same options, and then we're going to insert and again, not going to move it, we're going to insert a neck pickup with the same options, and again we're not going to relocate it, and we're going to insert the tool for the tool for the neck pocket for the donor neck type we're going to use. So here I'm going to assume that you can buy a Squire Strat for $50, pounds, euros on your local Facebook marketplace, and that you'll be taking the neck off of that. So, and voila. So if I just grab my 3D mouse and spin us around, you can see these are the bits of material that need to be removed from a guitar in order to mount respectively a Strat neck, a P90 in the neck position, a P90 in the bridge position, and the actual bridge. This is the tool for a Music Lily bridge that I typically buy from Amazon. It's about £16, and it's their Ultra Pro bridge. So it's quite nice actually. Certainly, I think worth the money over the £8 bridges you can get on Amazon. Anyway, so now we know. Now we've got these objects in here, we can use those as references for where our body needs to be. So let's now grab the top plane and put a sketch on it. And I'm just going to draw actually quite a classic, as in historically well-known-ish guitar concept of a big V shape. Now I'm going to constrain a few things. So I want the middle of that line, the origin, and that apex to all be in the one horizontal plane. Now I obviously need enough. I want exactly the amount of neck that I need and no more. So I'm gonna try and select the right things and make that coincident. So now I've got, this part that will become the body under the neck is gonna at least cover the screw holes. Now I can see, let's make these vertically. So if I drag one around, it will move both. Let's make these equal. Okay. So now I've got, the usual geometry tools. But I can see if I made the V like that, the pickup doesn't actually fit over within the body of the guitar, and that would be bad. So I'm going to use this as all those tooling pieces as my guide. Now obviously this wouldn't work because there's not actually material underneath where the bridge needs to be, so I'm going to have to pull that back. But at this point I'm doing primarily aesthetic body design. I can make the shape, the silhouette of the guitar be whatever I want, and then I can just dimension some stuff when I feel like it's appropriate to do so. Let's say that will be 350 then. Now obviously if I was going to actually print this guitar, which I'm not, I would I'd be paying a bit of attention to whether it will fit on the print bed of my printer, and I might be also preferring to so now we've got fully defined. That's all I was getting to. I might also be I'd prefer it to fit on the in two pieces on the print bed. So I made it 510 millimeters long there. That's actually slightly too long to be printed in two pieces on my on the printer that I own. So I would have to make this in three pieces, which would be slightly more annoying. So you got the freedom to the freedom you need to sort your to get things where you need them to be. Anyway, so here's my I'm going to extrude it 42 millimeters because that's the standard depth of guitars. And because of that, like a lot of things will assume that there is enough wood, pretty much that amount of wood for the screw holes. So these P90 pickups, for example, you can see there's only just enough material there for them to screw into, with it being 42 millimeters. And so 42 millimeters is kind of the mandatory minimum on the guitar body in general. I mean, that's true whether you're making it out of wood or plastic. But it's true if you want to be able to fit basically anything in there. Obviously, you can look at the tooling for the pickups you're using, and certain combinations will allow you to go thinner if that's what you want. And I've made the tooling deal with a body that is 10 centimeters thick, which I don't think anyone should want to go that thick. But if you want to play with thicker bodies, it should be it should cope with anything anyone might actually be able to play. So that's happened because merge result is ticked. So just untick merge result. There we go. But I think we might have a problem in a moment. Anyway, yeah, we will. So I'll see what happens, but I'm expecting this not to work. So the way this works, if I'm using SolidWorks, which is what I've been using to design these things, I use the intersect tool. I pick everything. I say intersect. I then click the body, which technically you're clicking at that point you're clicking the things you don't want, and then I click invert, because what I want is the body and not the other pieces. So here is a giant V-shaped guitar body that you could put a Strat neck into, and two P90s, and that Music Lily bridge, and mechanically everything would fit. Now, electrically, we still have some things to deal with. So I haven't finished. This is one of the unfinished pieces. Is I have to develop a standard for where the pickups drop their wiring, which is going to be to a sort of channel down here. And then, as the guitar body designer, it's up to me. I've not been able to make this tooling because there are too many design decisions available to the designer. So you're going to have to decide what knobs and switches you have, where they go, make appropriate holes for those, and you're going to have to make appropriate cavity inside of the body to attach those knobs and switches to, and so that you can do your wiring and make a cover for it. So I can't remove that piece of work or automate it away, but to be able to go from just the idea of what the outline of the guitar should be to something you could print this, you could bolt all those pieces of hardware to it, and it would certainly look like a guitar. And you should be able to, if you've appropriately reinforced it internally when you come to print it, you'll be able to tune it, play it. It won't do anything electrically because we haven't added controls and whatever, but if I hadn't been talking about it, that would have taken me 10 minutes less, maybe less, to make this shape. And this is, as I say, this is at a level where if I've got a Strat neck lying around and a couple of P90s and that bridge and a set of strings, I can hit print. Presuming my printer can print something this big, I can hit print and then come back once it's printed and I've got a guitar. This is as good as I can do right now with the technology we've got. The closest I can get to being able to make a Star Trek replicator style guitar dispenser. So yeah, that's basically that's the technology as I have it right now. Let me I'll give you random bit of luthiery advice. Sharp corners, not very ergonomic, so you're going to want to add some kind of chamfers or filleting or both to all of these outside surfaces in order to make it comfortable to play. And as you've seen on my guitar, it's helpful to have strap button locations, you're going to want to put those somewhere. And again, unfortunately, those are things I haven't been able to automate those away, because where the strap button needs to be is going to have to be different on this guitar than it would be on a guitar with curved surface. And I can't predict where the back end of your guitar will be, but I can, say you have to have a bridge here and the neck has to be this far away, otherwise you won't be able to tune the thing. Those are fixed things in the standards of the guitar system that you can't do anything about. So why do I make you? Why would we want to have to think about them when we can just make it as easy as this? So I'll just talk a little bit briefly about how 3D printable this is, and what thought's gone into it. So all of the through holes are hexagons or squares, and they're all oriented so that if you slice the guitar this way across this line in order to be able to print it, you won't have a overhang that's more than, do I mean more or less? It won't be more. So if this is 0, if vertical is 0 degrees and that's 45, 60 is where this design tops out. There won't be any more than 60 degrees. Due to the way slicers measure things, you may have to tell it not to put support on anything of 61 or more, just to make sure it only supports the parts that need it. But we don't have any unnecessary support for none of these. So these holes go all the way through, and the strings are going to go in there. And normally in a CNC wood-made guitar or handmade wood-made guitar, you would drill these holes and they'd be circles. If we did circles, you'd need support material to stop the circles collapsing on most printers. And so I've made them hexagons because it doesn't matter, but it means, to the guitarness of it, but it does matter to the printability of it. And you don't need, you don't need supports on any of these through holes. Any square hole is designed to have a screw put into it, and it's sized so that the screws that come with the bridge or that come with the pickups that it's designed for will go in there nicely, deform the plastic, so it'd be relatively hard to put them in, but you won't snap anything as you do. You won't hear any bad noises or whatever. So that's what the square holes are for. And then these hexagons for the neck are, again, they're designed to clear the screws that you use to hold on a Fender neck. And you've got a choice. If you're making one of these, you can either find a cap head screw of the right dimensions, so that has a flat bottom to press against this interior surface here, and then you can attach that with the screws recessed inside the holes, which is what I personally prefer to do. Or you can use the neck attachment plate that comes from your donor guitar, put that over these holes, put the screws through the thing, and it will fit the same as it did on the original guitar, because, to a first approximation anyway, all guitars are 42 millimeters thick, including this one. So the only pieces where you're going to need support if you print this are, you pretty much need to print, you do pretty much need to print it in this orientation, or equivalently in this orientation, so that the layer lines are oriented okay for the stress that they're under. And then that will mean that this surface or this surface will need support, and similarly this surface or this surface will need support. Now those are quite tall holes in that orientation, so you might be able to use tree supports and not have anything on the lower surface. What I like to do, if you because my printer has this capability, I like to slice it in exactly halfway between these two, so the two pickup cavities are at the same layer height as each other when I print them both on one plate. And then I like to use a interface medium on both sides, and because they're at the same layer for both of the components I'm making, it gives me no minimizes the number of tool changes required. But you don't have to do that. As I say, you can use probably tree supports in your slicer to get at the whichever is the upper surface when you print it, and then it is not going to matter if you do or don't use a different interface material. Finally, I haven't automated or haven't mechanized putting the steel rod down the middle of the back, and that's because, as I'm speaking to you now, I'm not certain what the exact best way of reinforcing that guitar is. So I have used the steel rod and it does work, but the issue with using that threaded rod is you need to expose a way to tighten it and retighten it, and it doesn't feel that nice to do that adjustment. It feels, you can feel the pressures involved, and it makes me feel a bit if I'm trying to say that making guitars now easy, it doesn't feel easy, if you see what I mean. So what I'm going to try is embedding a carbon fiber tube in the next one of these guitars that I make and epoxying it in there. I think that might provide enough stiffness to resist the bending of the strings if I put it in a reasonable place, in much the same way that the steel rod does, only permanently at one tension rather than having to be adjustable. Those tubes are less bendy than the steel rod is, which is interesting. And certainly once packed with epoxy into a print, I think it will work. It works in other applications that I've seen people use with 3D printing and embedded carbon rods. I don't know yet that it does work in this kind of guitar, but I'm hoping that it will. And I shall let you know one way or the other. I will say also, if you can print the body out of carbon fiber reinforced PLA, that will probably be better. I wouldn't use PETG for this. It's a bit too soft for some of the loads that it's going to experience. Regular PLA seems like it might be fine. Maybe on high tension strings it would be a bad idea, but for the application I've used it for, it seems okay. So anyway, this is a preview of the technology that I'm working on. As I say, I will standardize how the electrical connection of the pickups is conveyed to the rest of the body. I will probably, as part of that, add the grounding wire from the bridge in much the same way, so that will not be something you'll be free to change. One of the things I didn't do in this demo for you, but I could put in a different neck pocket and just change this intersect tool and have a different neck attachment. I could change the bridge and have a different bridge attachment. In fact, let's actually do that. So the way to do that is so I like to roll back the intersect before I do anything to the body. I like the intersect to be the last thing that happens to the extent possible, for reasons of being able to. So if I do untick all of those, yes, Okay, so we can see, I'll just put this in the bridges section. There we go. So you can see this new bridge will overhang the back of the body. Let's pretend that it doesn't though, and just or just ignore that problem for now. So I can edit this feature. I can take out that bridge. I can add in this bridge. Again, pick the pieces I want and just hide that bridge. And now we have the same guitar design, but with a different bridge system than what we had just now. And it took us, a minute or so to change that over, including loading the new bridge and me waffling about it. It'd be the same. So as I say, I don't have the other pickup tools built yet. It will take me a day or two, and I can't film every day, so have to film now, and then I'll do the remaining work later. But I've done them before in other CAD programs. It will not take me too long. It's certainly going to be possible. So it would, once I release this, it will be no more work than that to change from P90s to Telecaster style pickups or humbuckers or Strat style pickup layout or Jazzmaster style pickups. Those are the ones I'm intending to support. And similarly, it would be no more work than I just showed you to change from a Strat neck pocket to a Telecaster neck pocket. So you can, the point is, you can design a guitar body shape that is the body shape that you like. You can then add whatever pickups and whatever bridge is cheap for you to acquire and whatever donor neck is cheap for you to acquire. Print that out, test it, play it, confirm that you really like it, and then you can decide, okay, I want to do a more premium version of the same thing. I'm going to buy a fancier neck, I'm going to buy fancier pickups that are maybe a different shape, and I'm going to buy a fancier bridge. And all you will have to do is import the tooling for the fancier versions and do that one time, change the intersect command in your CAD program, and suddenly you've got the new body design. Now let me talk about my plan for making this not unique to SolidWorks and not unique to people who have SolidWorks Maker license, which is the license I have. I'm going to export these various tooling files as STLs and steps and 3MFs and the standard, probably all of the formats that I can think of. And then my proposal, then if you're using another CAD program that allows you to import those things and do the computational geometry with them, you can just do that. But the other thing I can do once I've got those STLs, I can make a little local tool. What that will do is use a open source CAD program called OpenSCAD, and that allows me to say, load this shape, load these other shapes, and then subtract the later shapes from the first shape in a programmatic way. And that means that whatever CAD program you want to use to design your body shape, what you do, let me just hide all these external parts. You're going to, if you provide this, and obviously you're going to have to add the controls and the where to mount the strap buttons and all of that, as we talked about earlier. But once you've got that done in your CAD program of choice, whatever it is, you can export that piece as an STL, and then using the tool that puppets OpenSCAD to do the work, it will load in your shape, and it will load in these whatever tools you've chosen from the menus, and it will subtract the tools from your shape and spit out the new STL for you. So I can make, whether or not you are using a CAD program that allows this subtractive geometry operation to happen, it doesn't matter, because there's an open source one that can do it for us. So that's how I intend to solve that distribution problem. And the other thing that I intend to do as part of that package is have a few standard body shapes. There's no standard guitar shape per se, but there's several widely known ones that people have produced technical drawings of, and I'll just make convert those technical drawings into a kind of so that they're correctly aligned on the datum that this software requires. So if what you decide that you want is some kind of T-type guitar, but with 2 Jazzmaster pickups and a headless bridge, you should be able to pick that from the menus without having to actually design anything in CAD yourself, and then you should be able to print it, and it should turn out working okay, right? That's what I'm aiming to provide for you. That allows you to be creative in the direction of like what filament are you gonna print it out of, what colors, that kind of stuff, and that, you know, even amongst the well-known body types and well-known pickup types and just the standard control layouts that those have and the bridges, there's still more guitars, more theoretical options for guitar in that than have ever been made in the world. So you can design something truly unique even without any creativity in the body shape department. I hope I've shown you that I have the capability to deliver on that, at least technically. It's now down to a question of my willpower and the time I have available, rather than can I do it. It's will I. And as I say, it is my intent to do it. That's my winter project for this year now, is looking like, you know, I want to mechanize all of this. I will let you know when there's any news, and if you have any comments of like what you would like it to be able to, what you'd like to be able to do with this that I haven't already said you can do, I guess let me know. I will then think about whether I can do it or whether it makes sense to try and do it. Thank you for your time. Thank you for watching. I hope it was somewhat interesting, entertaining, or, you know, I hope that I'm talking about something that someone out there actually wants to use. I've seen people ask about 3D printing guitars. I've seen people attempt it with varying levels of success in it being a guitar rather than just a guitar shaped thing at the end. I'm trying to, as I say, I'm trying to get the level of difficulty down to where anyone can design a new shape and turn it into a playable guitar. And thank you for coming along for the ride. If you're a 3D printing expert and you want to take this on and particularly and work on the how do you reinforce this so it can take the loads of a guitar, I'd be very interested to hear from you. I'd suggest you wait a couple of, hopefully it's only a couple of weeks till I've got the first version of the tool where you can just pick from drop down menus what configuration your guitar is and then go from there. But at that point I will not at that point know if a carbon rod down the spine is enough, or if does it need 2 carbon rods, do they need to be angled if there's 2, or can they be parallel, or are we forced to go back to steel all thread down the middle, blah blah blah. That I will not know by that point, and it strikes me that probably someone out there already does know the answer to what's going to be enough, and maybe they can just tell me, and then save me a bunch of development work. Anyway, if you would use it once it's out there, get in touch, and I'll make sure I poke you when directly once it is available, so that you know it's there. Anyway, cheerio. Have a good time until the next time we speak.